Cross-site scripting, or XSS, is a type of security vulnerability typically found in web applications. XSS enables attackers to inject malicious scripts into websites viewed by other users. These attacks are possible when a web application takes user input and sends it to a web browser without first validating or encoding that content. Imagine a website with a search bar. A user searches for laptops, and the website displays a results page that says, "You searched for laptops." An attacker might try to inject malicious code instead of a typical search term. If the website doesn't properly sanitize user input, the attacker's code will be sent to the victim's browser. XSS attacks can have severe consequences. They can lead to stolen cookies, session hijacking, and website defacement, among other risks. Protecting against XSS vulnerabilities is crucial for any website that handles user input. Let's break down a simple XSS attack scenario using a website's comment section as an example. First, the attacker injects malicious code. The website doesn't properly sanitize user input, allowing the attacker to insert a malicious script into a comment. This script could be designed to steal cookies, redirect users to malicious websites, or even take control of their accounts. The malicious comment is posted. Then, a victim views the comment. The victim's browser executes the malicious script. The script can access sensitive information like cookies, session tokens, or interact with the website as if it were the victim. XSS attacks can have a wide range of consequences, often leading to cookie theft and session hijacking. Attackers can use XSS to steal cookies stored in a user's browser. These cookies often contain sensitive information like session IDs, which can grant attackers unauthorized access to the user's account. This allows them to impersonate the victim and perform actions on their behalf. Data theft and manipulation is another risk. XSS can be used to access and manipulate sensitive data on a website. This could include stealing personal information, financial details, or even modifying website content without authorization. Website defacement is also a common outcome. Attackers can exploit XSS vulnerabilities to inject their own content into a website, essentially vandalizing it. This can damage the website's reputation, erode user trust, and even spread misinformation. Lastly, XSS can facilitate malware distribution. XSS can be leveraged to redirect users to malicious websites or automatically download malware onto their devices. This can compromise the victim's system, steal their data, or enlist their device in a botnet. Section 4. Types of XSS attacks: stored, reflected, and DOM-based. XSS attacks can be categorized into three main types. First, stored XSS. This is the most dangerous type of XSS attack. It occurs when malicious code is permanently stored on the web application's server. Second, reflected XSS. This type of attack occurs when malicious code is reflected back to the user who submitted it. Third, DOM-based XSS. This attack exploits vulnerabilities in the website's client-side code, specifically the Document Object Model, or DOM. Section 5. Preventing XSS, safeguarding your website and users. Preventing XSS attacks requires a multi-pronged approach. First, input sanitization. Validate and sanitize all user input before processing or displaying it. Remove or escape harmful characters. Second, output encoding. Encode special characters to prevent them from being executed as code. This prevents the browser from misinterpreting user input as scripts. Third, content security policy, or CSP. CSP controls the resources the browser can load. Define a strict CSP to prevent execution of inline scripts and restrict external scripts. Regular security audits and penetration testing are essential. This proactive approach maintains a secure web application. Section 6. XSS in the wild, real-world examples and lessons learned. Over the years, countless websites and web applications have fallen victim to XSS attacks, highlighting the importance of robust security measures. First, social media platforms. Social media platforms, with their vast user base and interactive features, have been prime targets for XSS attacks. Attackers have exploited vulnerabilities to spread misinformation, hijack accounts, and steal sensitive data. Second, e-commerce websites. E-commerce websites handling sensitive financial transactions are particularly vulnerable to XSS attacks. Attackers could exploit these vulnerabilities to steal credit card information, manipulate shopping carts, or redirect users to fake payment gateways. Third, online forums and communities. The interactive nature of online forums and communities makes them susceptible to XSS attacks. Attackers can inject malicious scripts into forum posts, private messages, or user profiles, potentially compromising numerous users with a single attack. These real-world examples emphasize the need for developers and website owners to prioritize security and implement best practices to protect against XSS vulnerabilities.